Today we're looking at standard deviation and variance. Now for both of those statistics, you can put all of the data into the calculator and it will show you what the standard deviation and variance is. We're not going to cover that today because as part of your exam, you need to know every single step of how to calculate it without just putting it into the calculator. For instance, in the exam you could have a half completed table and you need to finish it off, or you could be given parts of the calculations and you need to finish them off. So it's really important you understand the methods, but please also bear in mind that you can put all of the data into your calculator and get out the standard deviation and variance. Variation and standard deviation describe the average distance each of our data is away from the mean. The mean of this data is 6. We can draw a number line and measure the distances from the mean from each of our data. Notice that this first one's negative because it's -4 away. Then we've got the 3, which is -3 away. The 5, which is -1 away. We've got another 5 there. We've got the 6, which is a 6, so it's 0 away. Then the 7 is 1 away, and another 7, and the 8, and the 8, and the 9. Now what we can do is we can work out the average distance from mean, but the problem is that we've got all of those negative numbers. We've got the -4, -3, -1, -1. So to get rid of all the negatives, what we do is we square all of the numbers. And to work out the average distance, we add them all together and then divide them by the amount of numbers. So divide them by 10. So the average distance away from the mean, or the variance, is 4.6. But notice that we squared them, and that's going to be important later. Let's have a look at these questions. It's much easier to use a formula to find the variance. The formula we use for raw data is the mean of the squares take away the square of the mean. We can find the sum of the squares by adding up the squares of all of our data. The n is the amount of data we have, and the sum of the x is basically our data all added together. We can then substitute our values into the formula to find the variance. But notice with variance we have squared all of our data, and if you look at the symbol, it has a little squared sign there. The standard deviation, we undo that and put it in the same method or the same scale as our original data. So for the standard deviation, we just square root the 14.5. And that will give us 3.80 to three significant figures. And notice that the symbol for standard deviation is the same as the symbol for variance, but without the square sign. We can adapt the variance formula for when we have a frequency table. So notice that we no longer have sum of x, we have sum of fx. We no longer have sum of x squared, we have sum of fx squared. And we no longer have n, we have sum of f. The sum of the frequencies is just adding up all the frequencies in the frequency bit of the table. To find fx, we're just going to times the goals scored, the x, by the frequency, and we can add that column on, add them all up, and it will give us 11. To find the sum of fx squared, we're going to square the x first, and then we're going to times it by the frequency. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and then we're going to times those by the frequencies. Then we're going to add up that column, which will give us 17. Then we put those into the formula, and we get our answer of 0.576 to three significant figures. To find the standard deviation, all we need to do is square root that to give us our answer of 0.759 to three significant figures. We can use our variance formula for grouped data, but we must remember that we will need to add a midpoint column on. First of all, we can work out the sum of the frequencies by adding up the frequency column, and let's add that midpoint on. The midpoint of 0 to 10 is 5, 10 to 20 is 15, 20 to 30 is 25. Remember, if you're ever struggling with a midpoint, add the two numbers together, that say the 20 and the 30, and then divide by 2. 20 plus 30 is 50, divide by 2 is 25. Next, we'll need to add our fx column. Now remember, the midpoint is now our x, so we're going to do 5 times 5 is 25, 18 times 15, 22 times 25. And so we're going to add that together to find our sum of fx would be 845. We're then going to add an x squared column, and we're going to square the x's. The x's are our midpoint, so it's going to be 5 squared, 15 squared, and 25 squared. And then we're going to times those by the frequencies. Then add up that fx squared column, which will give us 17,925. We're going to substitute that into the variance formula, and it will give us a variance of 45.7 kilograms to 3 significant figures. Remember, standard deviation is just the square root of that, so the standard deviation will be 6.76 kilograms to 3 significant figures. Let's finish with this. To find the variance, we square the data, but explain why we then find the square root to find the standard deviation. If you know, write it in the comments below. And you can come to onmaths.com or click the link in the description where you can access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger GCSE course that you can follow along with at onmaths.com.